All right, looking at this one here, we have the fourth root of x to the 20th, y to the 8th. So, same deal as before. There's no numbers, just numbers. We just have x's and y's to powers in here, so we don't have to worry about factoring anything on this problem. So what I'm looking at here is the fourth root. And again, what I'm looking at as far as how to evaluate this, I take the power inside divided by the root outside. Division. So 20 divided by 4 makes 5. And then for y, 8 divided by 4 makes 2. In both cases, they divide exactly, no remainder, just an exact division. So 20 divided by 4 is 5, no remainder. 8 divided by 4 is 2, no remainder. Now looking at the problem versus the answer, 20 is even inside, 5 is odd outside, so I'm required to use absolute value bars. I'm going to put it, you can either put it around the whole thing or just around the x, doesn't matter, but let's put it around the whole thing. Let's do that. All right? If you look at this, 8's even, 2 is even, no concerns there. Okay, the reason we have to consider that is if x happens to be a negative number. If x equaled -1. It doesn't, but if it does, all right? X equals -1. X to the 20th power would equal +1, right? Because we have 20 negatives, which is even, which would be a positive. 1 times 1 times 1 all the way 20 times is 20, right? The answer, x to the 5th power, equals -1, because 5 negatives make a negative. So because of the possibility of a negative number existing in the problem, the letters could represent negatives. Even powers make them positive, odd powers make them negative. So the fact that the signs are different, we put the absolute value bars to ensure a positive result for that, because they have to be equivalent expressions. So again, without all that explanation, even in, odd out, put the bars. Even in, even out, don't worry about it. Odd in doesn't matter. Right? If it's odd in, it doesn't matter if it's even or odd out. But only the evens in matter. When you get an odd out, you put the bars. All right? In both these cases, everything was exactly evenly divisible by the root, so no leftovers. And again, the leftovers is what I want to consider. And again, I thought an example problem was going to cover that, and I didn't look closely enough before I did. So I will show you how to handle it when it isn't an exact division. Not hard to deal with, but just different.